Okay, we're going to start on our first notes today, and the way that in my class that you know a paper is notes is that it has a title up at the top in a little box, and it also has a page number. So you're going to put these papers into your binder in order as we take them, and you're kind of creating a resource for yourself. Okay, we're really doing a review of some things that you learned from Algebra 1 today, and we're going to talk about three forms of lines. Slope-intercept form, if you remember, is like the sweet spot. That's kind of, you want an equation to be in slope-intercept form so that you can make a graph. If it's in standard form, you're probably going to be switching it to slope-intercept form. Same thing, if it's in point-slope form, you're probably going to be switching it to slope-intercept form if you're trying to make a graph of a particular line. Point-slope form is the one that most students forget because we don't spend as much time on it in Algebra 1 as we do these other two forms, so we'll kind of take that one more slowly today. So I'm actually going to start with this problem because this one is already in slope-intercept form. So this is already an example of slope-intercept form. And those are sort of ready to graph when they're in that form. So the first thing that I do, of course, is grab my intercept. That's the y-intercept is 1. I'll put that point on. And then I'll use the slope to put some additional points on. Now, one good thing to know is that this fraction, negative 1/2, is the same thing as negative 1/2. So this is telling me to go down 1 and then go right 2. So that's a positive 2. So go down 1 and go right 2. Down 1, right 2. Down 1, right 2. It's also the same, when you write the fraction like this, it's also the same as 1/-2. So you can also think of that as going up 1 and left 2, right? Because it's rise over run. So go up 1 and left 2, like that. And there's my line. This line has a slope of negative 1/2. It has a y-intercept at 0, 1. And it has an x-intercept at 2, 0. Whenever we write intercepts, we want to write them as ordered pairs. So don't just put 1, put 0, 1. That's your y-intercept. So that one was already in slope-intercept form, which made it a little bit quicker to graph. This one is not in slope-intercept form. This is standard form. So I'm going to switch it into slope-intercept form so that I can graph it. I got to get the y by itself. So it looks more like this, y equals. So I'm going to start by subtracting 3x. Negative y equals negative 3x plus 6. And then divide by negative 1. Divide every single term by negative 1. And I get y equals 3x minus 6. There's my y-intercept. I'll put that on. And then my slope is rise 3, run 1. Rise 3, run 1. Rise 3, run 1. And connect them like that. Okay, the slope is 3. If you want to write 3/1, that's okay too, but rise 3, run 1. The y-intercept is 0, negative 6. And the x-intercept is 2, 0 also. Okay, probably in Algebra 1 you also had to deal with some vertical and horizontal lines. And those, you know, I forget these two. I'm going to be totally honest. And at least in my class, we learned, I mean, it's not super clever or anything, but we learned Hoy Vux as a way to remember that. So the H here is for horizontal. This is the slope. The slope is 0. And this tells you y equals. So a horizontal line is a y equals, not y equals 1. A horizontal line is a y equals line. So it's y equals a number. So in this diagram, I've got a horizontal line right here. That I know right away because of Hoy-Vux that that's a y equals line. Y equals negative 4 is this line. Vux, the V is for vertical. The U is for undefined slope. So a vertical line has an undefined slope. And X is for x equals. So it's an x equals line. So here's my vertical line. It goes through 2, goes through x equals 2, so that's the equation of the line, x equals 2. All right, let's look at these lines, and we're going to write the equations. Okay, let's look at line A first. Which one is line A? Oh, line A. I might need to highlight just to get my brain wrapped around this. This is line A. Right? And I see very clearly this point, but I also can see this point is on line A. So I'm writing a y equals mx plus b equation for line A, like a slope-intercept form equation. I see that the slope is rise 2, run 3, so y equals 2/3 x, and the intercept is -3, so -3. Line B is a vertical line, vux, so that's an x equals line. X equals -3. I'll go ahead and do line D right now because it's there. Line D is a horizontal line, so it's a y equals line. Y equals 4, which just leaves C. I'll put 2 points on C just so you can clearly see what the slope is. The slope is down 1 over 1. Down 1 over 1. So the slope is -1, -1x, and the intercept is actually at 0. So you could write that. It wouldn't be incorrect, but you can also simplify it, and you can write it as y equals -x. Just y equals -x. You don't even need the plus 0. Right? -1x is the same thing as -x. Okay, let's look at the back. Write the equation of a line that passes through these points. Now, I'm a person who loves a good graph, so there's an algebra way that you can do these, and then there's also a graphing way that you can do this. And so I'll do the first one with graphing, and I'll do the other, I'll do the next one with algebra. So you kind of get to choose which makes the most sense to you. If you're going to write an equation of a line, you probably want, it doesn't say which type of equation, but you probably want to do a y equals mx plus b equation. So I have to start the graph paper. If you need graph paper, it's in your box in the little blue bin at the bottom of the blue. You'll find some graph paper, so you can reach in there and get that. So -3, 4 is here, and 3, 0 is here. And if I connect those with a line, it goes like that. Okay. So I'm writing a slope-intercept form equation, right? So y equals mx plus b equation. So I need to figure out what the slope is, and it looks like it's down 4 and over 6, which is -2/3. So -4, 6 is -2/3. Oops, -2/3 x. Plus 2. B is 2. B is here. B is the y-intercept. So by drawing a picture, just connecting it, I can figure out what it is, the equation, because I need a slope and an intercept to do it. The other way to do these problems is using algebra. So if you don't like to draw graphs and you would prefer to use algebra, you can do the same thing. You first want to find the slope. And to find a slope, you need your slope formula. y2 minus y1 over x2 minus x1. I personally have to go through and label these because otherwise I start putting the numbers in the wrong places. This is x1, y1, x2, y2. So my slope is 4 minus -2 over 3 minus 0, which is 6 over 3, which is equal to 2. Okay, so now I got the slope. I need to figure out the intercept. Here's what I have so far. Y equals 2x plus b. Now to find b, I just have to plug in either ordered pair. I like the second one better because it's all positive, so I'll plug that in. Where the y is, I'll put 4. Where the x is, I'll put 3. And then I'm going to solve for b. So I'll subtract 6 from both sides, and I get b equals -2. So my equation is y equals 2x minus 2. 2 was my slope, right? -2 was the value of b that I calculated. So I can go like that. But again, you can also, just to be clear, you can also draw this, put a point at 0, -2, put a point at 3, 4, connect them, and find the equation of the line that way. Oops, sorry. Count the slope, rise 6, run 3, that's a slope of 2. Look at the y-intercept, it's just staring at you right there, it's -2. All right, last one. Now you can see that I prefer the graphing method, so I'm just going to go ahead and do the graphing method for the last one. It's 5, 2, and 5, -1. Well, that happens to be a vertical line through 5, and I know vertical lines, VUX, are x lines, so it's x equals 5. Did help me to draw a picture, though. All right. Point-slope form. Now, point-slope form, I find for students coming into Algebra 2 is like the hardest one, just because it's so unfamiliar. You probably spent just, I don't know, a day or two on it in Algebra 1, so it's not like y equals mx plus b where you were doing that all the time. Point-slope form, we don't spend as much time on it as we do in other classes. Okay. So with point-slope form, because I'm not as familiar with it, I always start with the formula, which I'm just grabbing from right here and kind of recopying it over on the other side so I can see it. Y minus y1 equals mx minus x1. Okay, so to write an equation in point-slope form, right, again, it might seem redundant, but I'm going to write y minus y1 equals x minus x1, and then I'm just focused on popping the pieces into the right places, substituting the values into the right spots. Okay, there's my slope. Slope is 1/2, right? And I need an x1 and a y1. This is x, right? In an ordered pair, this is x, and that's y. So where it says x1, x minus x1, so that would be x minus -4. Let me just write this here really quick just so we can all see it. X minus -4 becomes x plus 4, right? So that goes here. And y minus y1 is y minus 5. That is point-slope form. That's it. We're just going to plug in the point. Literally, it's called point-slope form because what you need to know is a point and the slope. Okay. Now, one of the things that happens that I do regularly here is convert it to slope-intercept form. So I'm going to take this, and you might guess there's parentheses here. I'm going to distribute 1/2 x. 1/2 times 4 is 2. I'm trying to get it to slope-intercept form. That means I need to get the y by itself, add 5 to both sides, and you get y equals 1/2 x plus 7. And that's the slope-intercept form of the same equation. Point-slope form, distribute, move the 5 over, and now we have slope-intercept form. Now, one other concept that you learned in Algebra 1 is you learned about parallel and perpendicular lines. And I got to really zoom in on this for you to see it, and maybe focus it too. Okay, there we go. Okay, two lines that are parallel, like these two. There are the equations, 2x minus 3 and 2x plus 4. What you got to notice about them, if they're parallel, they have the same slope. Okay. If they are perpendicular, their slopes are opposite reciprocals. And here's what I mean by opposite reciprocals. Here's an example. 1/2 becomes -2, I'm going to put it over 1. If the slope of the first line is 4/5, opposite reciprocals means you switch it and you change the sign, like that. If the slope of the first line is -3, well, that's -3 over 1. Whoops. And you would switch it to +1/3 to find the slope of a perpendicular line. So this is what we mean by opposite reciprocals. The signs are opposite and you flipped it. Okay? So let's look at a few examples over here for parallel and perpendicular lines. If you know the first line is y equals -3x plus 4, then you know a parallel line has a slope of -3. And a perpendicular line has a slope of 1/3. Okay, because this -3 is -3 over 1, and you're going to flip it and change the sign. If you know that the slope is 1/2 for the original line, a parallel line will have a slope of, that's the same slope. And the perpendicular line will have the opposite reciprocal slope. So 1/2, we're going to flip it and change the sign. So that's -2. Now this next one's kind of a pain in the butt because it's written in standard form and I want it in slope-intercept form. So the first thing that I really have to do is switch it to slope-intercept form. -4x, -4x. I'm isolating the y here. Divide by -5, -5, -5. We did this on the front page. Okay. There's the equation. Once I switched it, it's 4/5 x minus 2/5. So a parallel line would have the same slope, 4/5, and a perpendicular line would have the opposite reciprocal slope. Maybe I'll have to squeeze this underneath here. Y equals 4/5 x minus 2/5. Okay. X equals 4. An x equals line. Let's see what that's going to look like. X equals hoi vux. X equals line is going to be a vertical line at 4. My number line. There's x equals 4. 1, 2, 3, 4. Vertical lines have undefined slopes. Vux, that's the vertical lines are x equals lines and they have undefined slopes. So the slope of a parallel line will be undefined and a slope of a perpendicular line, like this one, will be 0. Oop, you can't see that though. There's my perpendicular line. The slope of that line is 0. Drawing graphs. Y equals -2. I want to visualize this one too. Y equals -2. Okay, that is a, use a different color. That's a horizontal line. It's a y equals line. That's a hoi line. It's y equals -2. Its slope is 0, and a perpendicular line to that would have an undefined slope. Y equals x, that has a slope of 1, because there's really a 1 right there. So the perpendicular slope is -1. Okay, last question at the bottom. In point slope form, write the equations of parallel and perpendicular lines to negative 2x plus 1 through the point 4, 6. Now, it says, again, point slope form, so you know what I got to do. I got to write down point slope form. Okay. If it's parallel to this, the slope is the same. And this is my point. Point slope form, all you need to know is the slope, which is the same, and a point. x1, y1. So this would be x minus 4 and y minus 6 over here. That's the point slope form. It doesn't say that you have to switch it to slope intercept form or anything. It says write it in point slope form. If it's perpendicular, and again, this might seem redundant to you, but for me, I need a little extra help with point slope form. If the line is perpendicular, then I know that the slope is going to be positive 1/2, because you're going to take that negative 2 over 1, and you're going to flip it and change the sign. Oopsie, 1/2. I didn't flip it. 1/2. Okay. There's my new slope for a perpendicular line. And then x minus 4, right? That's x1. Y minus 6. Okay. All right. You should use the rest of your class time to work on P1, which is equations, all about lines. It's the practice assignment. And what I'm going to do is I am going to post the answer. Well, actually, no. We're going to check them in class next time. So bring your paper back next time, and I'm going to show you how to check them using the answer keys that I'll provide. Okay. Good luck. Have fun.